All right, we're moving on to page 4 of the practice final. Let's keep it going here. Number 18, simplify each expression. All right, so what we have here is a problem as the numerator, right? We have a fraction, take away a fraction as the numerator, and we have another fraction in the denominator. So we have a complex rational expression here. Let's begin by simply working on the top. I'm just going to forget about the bottom for a moment, pretend that this is my only problem, that I need to subtract these two fractions. Of course, I need a common denominator. So the common denominator will be r times r plus 2. r times r plus 2. So I'm going to modify this first fraction to become this fraction, all right? So if I have an r down here, but I need an r times r plus 2, obviously it's missing the times r plus 2. So what I do to the bottom, I do to the top, times r plus 2. And of course we have a binomial times a binomial. So we have r times r, that's r squared. r times 6, that's positive 6r. 2 times r, that's positive 2r. And 2 times 6, that is positive 12. So the quadratic trinomial that I have on the numerator of my first fraction up there is r squared plus 8r plus 12. Now this is my new modified first fraction, changing that r to the LCD r times r plus 2. Let's do the same for this one over here. We have a minus sign in between the two fractions, but of course that other fraction, it's not going to just be the r plus 2, it's going to be the LCD, which is r times r plus 2. So what do I need to do to this denominator to make it look like this r plus 2 times r? It's obviously missing an r, so let's multiply this binomial by an r. So I'm going to put it times r, and what I do to the bottom I must do to the top, times r. So I have 1 times r, which is r. So here we go, guys. What have I done so far? I've taken both fractions and changed both fractions so they could have a LCD, common denominator, so that I could actually combine this numerator with that numerator. Okay. So we really have, let's actually combine them and put them over, I'll do it over here. Let's combine them and put our final answer on the numerator section of this problem over that common denominator, that LCD of r times r plus 2. So what do I have here? I have r squared. There is no other r squared, not even minus r, so just r squared just moves over. There it is, r squared. How about the 8r? 8r take away 1r. 8r take away 1r is 7r. So I have plus 7r. And last but not least, the 12. There are no other numbers to combine it with, so you just bring over the 12. Plus 12. Ladies and gentlemen, that's what we have as the numerator, okay? The numerator, that is correct. Now, yes, we're going to be able to factor this later, but right now this is the numerator. Numerator. Or you could just say top, whatever. But let's go back to the original problem itself. And now we have this denominator to deal with, okay? Let's zoom in and deal with that denominator. We do have a quadratic trinomial where the a value is 1. So that's pretty simple to factor, right? You have r times r, that would give you the r squared. And we simply think, what times what is the c value that if you combine together is the b value? So what times what is 3 that if you add together is 4? That's going to be a positive 3 times positive 1, right? 3 times 1 is 3. 3 plus 1 is 4. How about that denominator? On the bottom, we're going to pull out the GCF, which would be just the letter r. So I could pull out an r. Actually, might as well do it over here. Pull out the r. What's going to be left on the inside? If you pull out one r, you're going to have one r left. So I have r left. And pull out an r from this one, you'll have just a positive 2. Positive 2. So I hope we understand how we got from this quadratic trinomial to this guy. We factored it. And how we got this quadratic binomial to this guy. We factored it. Pulled out the GCF. Anyways, this is what we have on the bottom. This is the denominator. Denominator. Or bottom. Anyway, what do we have on top? What do we have on the bottom? This is what we have up on top. This is what we have on the bottom. So we know it is this divided by this. Okay, so let me rewrite it. I'm going to rewrite it. As a matter of fact, well, you guys would have to rewrite it. I could just do this. I could just cut it like this and then just move it over. There, I rewrote it. And I'm also going to rewrite this one. and put it over here. Now there is a division sign between the two, right? Instead of writing it vertically, we are going to write this horizontally. That's what we did. So we know that when we have a fraction divided by a fraction, we're really going to be changing it to multiplication of the reciprocal of that guy. So once again, we need to rewrite the first fraction. And as I'm looking at it, we might as well factor whatever we possibly can. All right, so I see a quadratic trinomial. So let's begin writing our first fraction over here. But instead of the r squared plus 7r plus 12, let's actually factor that. Put r, and then think what times what is 12 that if I combine together is 7. That'll be a positive 3 times a positive 4. That'll give me a positive 12. If I combine it, it does give me a positive 7. And it is over r times r plus 2. Now that's in factored form already. That's great. That's what I want. And now this division is going to change to multiplication. Okay, so this division right here is going to change to multiplication over here. And of course, the only way we could do that is if we flip the second fraction. When you divide by a fraction, you really multiply it by its reciprocal. So I'm going to rewrite this fraction right here, but of course I'm going to flip it. So here it is. We have a r times r plus 2 up on top, and we have a r plus 3 times r plus 1 on the bottom. Now we have pure multiplication. We have a binomial times this other fraction, right? R times this binomial. It's all pure multiplication, which means that we could cancel anything that we see up on top that is exactly the same as the bottom, or vice versa. So we have this r plus 2 up here that cancels with that r plus 2. We have this r plus 3 up here that cancels with this r plus 3. And we also have, I almost said that we were done, but we're not. We have an r right here and an r right there. Those guys cancel out. What is left? We have the answer r plus 4 over r plus 1. That is your answer. Let's take a look at the multiple choice options, and I could see it right here. Option D. Jump into number 19. Oh yeah, fun stuff. Whenever you have fractions with quadratics, with variable expressions, always try to factor anything possible and then try to cancel, right? So even before beginning, how about we focus in on this numerator, and let's start doing those steps to factor that quadratic trinomial that has an a value of 2. Step 1 is to multiply a times c. Of course, a is 2 and c is negative 15. We will get negative 30 as the answer to step 1. Step 2 is to think of the multiples of negative 30 that combine together to give you the middle value, negative 7. Right? So if you don't see it right off the bat, make a list. Negative 1 times 30, negative 2 times 15, negative 3 times 10, and you should see right there, hey, wait a minute, negative 3 times 10, that gives me the negative 30, and if I add those together, does it give me the b value, negative 7? It gives me a positive 7. So I have the right number, I just have the wrong sign, right? I have the right numbers right here, I just have the wrong signs. So I need to change this to a positive 3 and to a negative 10. Okay, so step 3 is either to, if it depends which route you're going. If you want to go the long route, you want to change your trinomial to a 4-term polynomial to be able to factor by grouping. That's where you replace this middle value, negative 7s, to become a positive 3x minus 7s. Getting 4 terms, then you could factor by grouping. Or that amazing shortcut that we learned to plug it into the format with your parentheses, whoops, I'm sorry about that, with your parentheses right here, and you're going to plug this in right here and right there, but without the square. It's your 8x term. In this case, it's 2s. All right, so just ignore the square and put 2s right here and right here, 2s. That's what I'm going to do, 2s, 2s. And what do we do with these blank spots? We're going to take these two numbers from step 2 and just plop them right in there. So you will have a plus 3 and a minus 10. And we know that this is wrong so far because 2s times 2s is 4s squared, not 2s squared. So we know that we need to magically divide or magically factor out the GCF of whatever you can on whichever binomial. So 2s plus 3, there's nothing in common right here. 2s minus 10, we could actually divide that binomial by 2. So if you divide that binomial by 2, it'll be a single s minus 5, because 10 divided by 2 is 5. Now the first binomial stays the same, 2s plus 3. There's nothing that you could divide by. So ladies and gentlemen, this is your factored form. This right here is your factored form of that above quadratic trinomial expression, 2s squared minus 7s minus 15. If you were to distribute and combine like terms, you'd get back to here. Anyways, we will replace this with this in a couple of moments. Now this is technically already in factored form, s plus 4. I mean, if you want to, you could write it out 2 times, s plus 4 times s plus 4, but please do not distribute, right? We want it in factored form. We don't want it distributed. So leave it in factored form. And now over here on this other one, whoops. On this other one, let's see what we could factor. We can't factor anything down here, but we could factor this top one. I want to factor it to what times what is positive 25, that if you combine together is negative 10. That'll be a negative 5 times negative 5. I really dislike s's when they're right next to 5s. They're confusing. Anyway, we have the factored form of this, which is right there. We have the binomial times binomial down here in factored form. That's good. We have the binomial times binomial up there in factored form. This, you can't do anything with it. So we are ready to change this division to multiplication and then flip that second fraction. Okay, so before we start flipping any fractions, let's rewrite the first fraction. All right, the first fraction is going to be 2s plus 3 times s minus 5 over s plus 4 times s plus 4. And now we're going to put multiplication instead of division, and we're going to flip this second fraction. So that s plus 4 that was at the bottom is now going to be s plus 4 up on top. And this factored form of the quadratic trinomial, this factored form s minus 5 times s minus 5, we are going to write it at the bottom. S minus 5 times s minus 5. So now that we have everything in factored form, now that we have all pure multiplication, now we could start canceling things out. So we see that there's a s minus 5 up here that could cancel with that s minus 5 down there. We also see that there's a s plus 4, the entire binomial up on top, s plus 4, cancels with the s plus 4 down there. And ladies and gentlemen, that is it. What do we have left over as an answer? We have this 2s plus 3. That's all we have in the numerator, and that's obviously option D. And then what do we have in the denominator? We have the s plus 4 times s plus 5, s plus 4 times s plus 5. Ladies and gentlemen, there's our answer, option D. Number 20, fun stuff. I know. Can't believe it, huh? You're not paying any money for this amazing entertainment? Yeah. Anyway, number 20, factor anything possible. You can't do anything with the above first numerator, but you could factor out a 2 on the denominator, right? So when you pull out a 2, you'll have a 5x minus 1 left over. And how about up here, the 25x squared minus 1? That is a difference of 2 squares, right? You could think square root 25x squared, square root 1, and plug it into your answer format, your factored form answer format, which is 5x plus 1, 5x minus 1. And again, we weren't able to do anything with that top one, so we just leave it like that. I'm putting it in parentheses just so it'll look like the other binomials. And down here in the denominator of the second fraction, what times what is the c value, 25, that if I combine together is the b value, negative 10, negative 5, and negative 5, right? Negative 5 times negative 5 is positive 25. When you combine it together, it is negative 10. Anyway, I have factored everything, okay? So I guess to save time, I'm not going to rewrite it all. I already changed this x minus 2, I changed it to become this. And this 25x squared minus 1, I changed it to become that. And so it's all right there. So what could I cancel? What's alike? I have the x minus 5 up here that cancels with one of these x minus 5s down there. Then we have the 5x minus 1 up here that cancels with the 5x minus 1 down there. And what is left, nothing else cancels. What is left? we have the 5x plus 1. Actually, let's zoom out a bit so we could look at those multiple choice answers. We have the 5x plus 1, and the only one that has a 5x plus 1, it's either B or D. And then what's left over on the bottom, we have 2 times x minus 5. 2 times x minus 5. We have a winner, option B, not D. Okay, let's move on to 21. Okay, on number 21, I'm assuming there's a typo because it says for what values of x is the expression, bleh, there's nothing there. What's happening? Okay, I'm assuming it's saying for what values is this expression undefined? Okay, I'm assuming. I hope that's the case. For what values is this expression undefined? Well, what would make this undefined? A -4 would make this undefined, right? But you know what? Instead of jumping right into thinking what value will make it 0, right? Because when you divide by 0, it becomes undefined. Instead of jumping right into that, I mean, that's pretty clear right there. But how about this guy? Let's take a look at that 9 minus x squared. And let's understand, first of all, it's not in the correct order. So I'm going to take this 9 minus x squared and I'm going to rewrite it as negative x squared plus 9. And then I'm going to factor out a -1 so I could have a nice, beautiful positive x squared. And of course that plus 9 becomes a minus 9. But then I notice that on the inside of those parentheses that I just made, I have a difference of 2 squares, which means I could factor that further, thinking what times what is -9, that if I combine together is a middle value, which is nothing, that'd be a +3 and a -3. Or of course you could square root both, but anyways, plus 3 minus 3, bring down the -1 in front. So this is actually rewritten as this in factored form, okay? And of course the x plus 4, it's already simplified, I mean it's already factored. And the fact is, when you're trying to determine what values will make it undefined, you're trying to determine which values will make it 0. So it's pretty clear that x equals -4 will make it undefined, right? Okay, so normally we state that we do not want x to be -4, but right here I guess they're asking you what values will make it undefined. Instead of saying x cannot be -4, they want us to actually say what number will make it undefined, so the answer is -4. Now how about over here, this factored form binomial, when we factor it out, we need to set that equal to 0 as well, okay? So let's make this equal 0, and we could use the 0 product property, okay? And we'll have x plus 3 equaling 0, x minus 3 equaling 0, and the -1, you don't even have to worry about it. It'll be x equals -3, x equals +3. So those values will also mess this up. And it's pretty clear. I mean, you could actually verify that. A -3 right there, -3 squared is +9. 9 take away 9 will be 0, and it doesn't matter what you get over here. 0 times that will be 0 in the denominator, which will mess it up. And also the 3 squared is also +9. 9 take away 9 is also 0. So the values that will make this rational expression undefined, if that's the actual question they're asking, is x is -4, -3, and +3. -4, -3, and +3, and that is option C right there. Oh yeah, number 22, solve this logarithmic inequality. Fun stuff with the capital F. That's right. Anyway, logarithms, when you have the same exact logarithm, log base 8, equaling or greater than log base 8 over here, that's pretty simple. You just raise both sides of that inequality to become powers of base 8. That way the logs disappear. Just like any other equation, when you want to get rid of something, you do the inverse operation. The inverse of a logarithm is an exponent. So we're going to raise both sides to become powers of base 8. Okay? And those will eliminate. Okay, it rhymes again. So what do we have left? We have a 4x minus 7 that comes down is greater than x plus 11. Okay, let's continue solving here. We're going to move the x over to the left side. We end up with 3x minus 7 is greater than 11. add 7, we end up with 3x is greater than 18. Final step is to divide by 3. We're not dividing by a negative, so the inequality does not flip. It's x is greater than 6. Now, some of us think, oh, I see it right there, circle it, and it might be wrong. Why do I say that? Because remember, guys, we're dealing with a logarithmic inequality. We're talking about an area, right? And we know that we cannot have negative numbers, like a negative, you can't do the logarithm of a negative number, right? You can't have log base 8 of negative 8. It's impossible. It's undefined. It doesn't work. Over here, you can't have a negative value in here also. So what we need to do is say that I need this to be 0 or greater. Okay, so let's actually write that down. The 4x minus 7 must be greater than or equal to 0. Okay, that 4x minus 7 must be greater than or equal to 0. Likewise, this x plus 11, the x plus 11 must also be greater than or equal to 0. Okay, because it can't end up being negative. And if this is negative, the whole thing is messed up. Okay, so we need to solve these two simple inequalities. Plus 7, you'll have 4x is greater than or equal to 7. Final answer, x is greater than or equal to 7/4. Over here, subtract 11, and you will get x is greater than or equal to negative 11. So we have these three answers, these three inequalities, and we must represent the overlap piece, okay? So let me do this. I am going to use this rectangle by bringing it to the front. And I want to draw a number line right on it with those answers. So here's my number line. I know it's disgusting. I should have used a ruler. Let's plot the points. We have negative 11 over here on the left side. We have positive 6 over here on the right side. And 7/4, that's a little bit less than 2. It's 2 3/4. So 7/4 will be somewhere right here. And of course, 0 is somewhere over here. I guess technically 11 should be further that way. But anyway, let's plot these inequalities on this number line. So let's do this one in green. X is greater than or equal to 7/4. Greater than or equal to, solid dot going to the right. Okay? Let's keep going to the right. Let's do this next one in red, since it's in red. X is greater than or equal to negative 11. Greater than or equal to negative 11. Okay, and how about this last one? The x is greater than 6. Let me do that one in yellow. X is greater than 6. So yeah, in this particular case, we wanted to represent the overlap of all three. So the triple overlap, where's the triple overlap? It is, let me highlight it. It is right here, that way, okay? So yes, in this case, the only answer is x is greater than 6. But then again, I must show you this because if the red one pointing this way, this one pointing this way, and the yellow one points that way, then it would be a compound inequality between 7/4 and 6. So with that said, we know the triple overlap piece is just on the x is greater than 6. Okay. I know it's a long video, but we are almost done. Number 23, what do we have here? We have a radical function, a square root function, and we need to determine which one of these it is. So here's the form of square root functions. Y equals a square root x minus h plus k on the outside of the square root. This is true with vertex form equations and many other types of equations that we've been dealing with in this class. Now this is a dotted line here. So as you can see, that is an inequality and it does not have a or equal to. None of these have or equal to, so far so good. And it is shaded below that curve, which means less than. So automatically, wow, is it really that simple? This is the only less than one? Yeah, that's your answer. Okay, but that's ridiculous. Let's keep explaining here. the original parent graph starts at 0, 0 and shoots off in that direction, right? I hope we remember that from class. And we know that if it shifts 2 units to the right, that must mean that it's going to look like a x minus 2, right? Because if it does go to the right, it's going to be a minus 2 right there for the h. And that's exactly what this is, right? This one is saying that the original parent graph got shifted 2 units down. So it would look like that for this one. This one is saying that it got shifted 2 units up. So it would look from here or from here to going that way. So yeah, this is the h shift of positive 2. And that's exactly what happens on h shift of positive 2. And same thing here, but this one is less than, which means that it's shaded below. Greater than would be means that it's shaded above. Well, that was easy. Number 23. Another square root function. But what are they asking for? Actually, this is 24. What are they asking for? State the domain and range. Okay. That's easy. Okay, so the domain obviously are your x values, and this is starting at -1, and it does go to the right forever. So the domain is x is greater than or equal to that -1. Going to the right is greater than or equal to. So far domain is greater than or equal to -1. So far we are good, or it could be this one over here. Now the range are your up and down values, your y values, and this beginning point is at the y value of 0, and it only goes up from there. Even though it curves, it still continues to grow higher and higher and higher. So the range is y is greater than or equal to that 0 value. So that's what it says here. Range is y is greater than or equal to that 0 value. So option A is the correct answer. Okay, let's move on to 25. Population is growing continuously. I can't even speak right now, sorry. Population is growing continuously at a rate of 3%. If the population is now 5 million, what will it be in 17 years? And they tell you that formula to use y equals a. So we're going to go y equals a is the initial amount, and we're talking about 5 million. Probably should have actually did the 6 zeros. I don't know why I did that. Anyway, so we have 5 million times 1 plus the rate. The rate is obviously this percent. However, you want to write it as a decimal, not as a percent. So that would mean that you move the decimal over to the left 2 times, and that will be 0.03. Okay. And then, of course, you close the parentheses, and it's to the power of t, and t is time, right? T is time, and we're talking about 17 years. So it's going to be to the power of 17 right there. So let's work this out. On a calculator, I'm going to go 1.03 to the power of 17, and then I'm going to multiply that by 5 million. So what I did here is I rewrote this as 1.65. Of course, it's irrational. It goes on forever, but I just left it at 1.65, and now I'm going to multiply that by 5 million. If you do that on a calculator, it's about 8.3 million. All right, so there is your answer. Use a calculator, please.